Okay. Francisco.
How many lines does this one take?
Too many.
At most 6.
Okay,
Like I said, too many.
I got enough.
All right, so this one is a particle motion problem. So we have a particle P moves on the number line shown in part A of the accompanying figure. Part B shows the position of P as a function of time t. And it says A, when is P moving to the left, right, and standing still? Francisco. Oh, I love that movie. He says, what movie? Or Wizard of Oz. Also, 10 out of 10 recommend that one. Wizard of Oz.
I honestly, like, I know everything about Wizard of Oz, but I feel like I cannot tell you, like, if I've seen the whole movie. Like, I feel like it's just one of those
So
things
good.
that, like, I can't remember if I have or haven't.
So good.
Nice.
Okay. Anyway, so we're looking at this and we're looking at the different things about the slopes to determine what's happening and where it's like not moving and things like that. So if there's a positive slope, it's moving to the right. A negative slope is moving to the left. And if it's standing still, it's a flat line. So this might make some of what we did in physics make a little more sense now. So, what's happening from 0 to 1?
To the right.
It's moving to the right. Anywhere there's like an endpoint, so like at 0 or over here at 6, we'll do or equal to's. But if it's just like in between here, because this can go either way, it's not included, so it's going to be just less than or just greater than, depending on obviously what we're doing. Or well, I guess they're all technically less than, but what's happening from 1 to 2? Still. What about 2 to 3?
Left.
3 to 5?
Still.
And 5 to 6.
Left.
Yep.
Got my direction.
All right, so just to write it down now. From 0 to 1, we are moving to the right. So 0, less than or equal to t, less than 1. So again, it's or equal to because 0 is an endpoint. From 1 to 2 is still, so 1 less than t, less than 2. Things are running together.
1 is less than 2. So. Be wrong.
True. 2 to 3 is left. So 2 less than t less than 3. 3 to 5 was still. So 3 less than t less than 5. And finally, 5 to 6 was left. So 5 less than t. 6 is an endpoint, so less than or equal to 6. Word problem. Free fall. The equation for free fall near the surfaces of Mars and Jupiter, S in meters, T in seconds, are for Mars. We've got S equals 1.86 T squared. For Jupiter, actually, I'm going to write Jupiter to the side so I can write underneath of it. I've got S equals 11.44 T t squared. How long would it take a rock falling from rest? So I don't really think that's relevant to this particular problem, but just so we know. From rest to reach a velocity of 16.6 meters per second. That's velocity. So I have position. To get to the velocity function, I need to take the derivative. So what would the derivative of this function be? And notice the derivative of position is velocity. So when I take the derivative, instead of it being s prime, I'm going to write it as v.
3.72 t.
And what about for Jupiter?
22.88 t.
I'm not sure it's like
So if I want to know time, because it wants to know how long it would take, I need to set up this equation. So velocity is equal to what?
like, is that the 16.6?
Oh, I'm looking for an equation.
It's like,
So velocity is meters per second, right?
it's like distance times time. Is that what you're looking for?
More or less.
Yeah.
Okay, so when I go to solve this, I'm going to have the distance. Nope, I lied. The time. 16.6 meters per second.
Where's the time?
I'm saying the wrong word. The velocity is getting plugged in here,
Okay.
and I'm dividing by this to solve for time.
Okay.
Words aren't working if you can't tell.
I thought that's what we were gonna do at first, but then I was like,
So 16.6 divided by 3.72 equals t. So t equals
West Virginia. All that. Oh, okay.
where's yours?
Yeah.
It's in my bag. It wanted to take a nap, so.
Hasn't it been taking a nap all day?
Yeah, but it didn't want to be disturbed.
Okay.
Mm-hmm.
4.46.
Seconds. So that's for Mars. Same thing over here for Jupiter. 16.6 divided by 22.88 equals t. So t equals
That one just goes like,
0.73.
seconds.
I figured out the other day that my grandma does the wh- like
Wheat.
me off guard. I was like,
These things look vacuum.
20.
Sounds kind of like those things at the dentist.
I hate the dentist.
You know, the things that go like.
I hate that thing.
The sucker?
Yes.
The
The Spitsucker, I love that thing.
Oh, I hate when they spray a bunch of water in my mouth and they're like, here, let me just like get that up here. And they put it in for like a millisecond. I'm like still like there's so much water in my mouth.
They leave mine like in there
Same.
the entire time they're doing it. And then every once in a while she'll be like, all right, close. And then it's like,
Like, whoa.
and then I like open and then she's like, all right, ready to go again.
I don't
Yeah.
know what Dennis I've been going to.
I don't know
They
either.
like spray with a bunch of water and then she'll just be like, here, do you need some? Because I'm like sitting there like choking on the water and then she puts it for like a millisecond.
So you're like,
And then I'm like, more.
that almost came out my nose.
That would be gross.
That'd be nasty.
All right, so we've got a particle moving along a line, so its position at any time t greater than or equal to 0 is given by this function I've written here, where s is measured in meters and t in seconds.
My eyes burn now.
I know how I feel when I'm at the dentist.
Find instantaneous velocity
I had water come out my nose.
at time t.
After I brush my teeth.
What?
I had water come out of my nose this morning. It was after I brushed my teeth.
I
Feel
forgot
like-
to tell you what happened to me on the way back from Bible. I went to fling my backpack over my shoulder because it kept falling off, and my my laptop blew out of blew. Like everyone turned around in the hallway. It still turns on. Only one little thing broke off.
What?
It's still rolling.
Where?
Like where I plug it in, there's a little piece like where I put my HDMI cable in or whatever, like the little piece that like it's just broken off. But I think it'll still work. It's got some scuff marks on the side. Oh well.
All right, find instantaneous velocity at time t. How do I do that?
Take the derivative.
So v of t equals what?
Negative 3t squared plus 14t minus 14 plus,
Yep.
that's it.
B, find the acceleration at time t. That's gross.
Yeah.
I said that's gross. Random side note, but pretty soon we might have a unit circle quiz. Because the next section is trig.
I need to look at that. Oh gosh.
Alright, how do I find acceleration?
What we just did.
Like, go to take
Oh
the
no, that was
derivative.
velocity. I don't know. I did that on my last quiz. I don't think I should be answering these questions.
So, velocity is the derivative of position. So, what do you think acceleration might be in relation to velocity?
Time.
The derivative of velocity.
Oh,
That would have been right.
I wasn't
Well, that's-
making fun of you.
That's not what I meant when I said it, but the way you said it, you thought I meant that. And he was like, what?
Or acceleration is the second derivative of position. It's another way to think about it. So,
So we just take the derivative again.
Plus
yep. What do we get when I do that?
negative 6t plus 14.
Virginia's got this under control.
I got it.
So what would come after acceleration?
Jolt. Which in this case would be -6.
Is there anything after that?
At least not that I've ever seen.
What happens if there's only like it only goes up to squared? Like when you get to jolt, which would be 0.
Mm.
What if it doesn't go to squared? Is there just no acceleration? Well,
Pretty much.
Yeah, I guess it wouldn't be acceleration because it's just a line to start with. So
Okay, part C. When is the particle at rest? So it would be at rest when velocity is equal to 0. So negative 3t squared plus 14t minus 14 equals 0. Follow-up question, can I factor?
Can I take out a negative so that I can brain it more easily?
You can, but it doesn't factor.
I'm gonna say no.
You weren't supposed to tell me.
Trying to speed this process up. We don't have a lot of time.
Chop chop.
I guess we just need a little more acceleration.
So what might I need if I can't factor?
The quadratic
The
formula.
terrifying thing.
Negative 14 plus or minus the square root of 14 squared minus 4 times negative 3 times negative 14 all over 2 times negative 3.
You sound like a sports person. Like, alright, I'll go with like that. Sounds like what is this?
Like a what?
Like a sports announcer.
I was thinking like Busch Gardens worker, but that works too.
Maybe that's what I'm thinking of. I'm like, I know it's something.
Like pet shenanigans.
It's almost solved.
Is it bothering you? Alright, negative 14 plus or minus.
There we go.
Let's say Virginia, you got that number that goes.
96.
What about this
Oh.
this
Yeah,
part? Just to
Virginia.
give me the whole thing since we're.
Virginia.
Okay.
I was about to say 128 and I knew that wasn't right, so I just kept my mouth shut.
Yeah. 28.
So 128 would have been
Close enough.
almost there. Same thing.
Over negative 6. And then we need to solve each of these individually.
You got this, Virginia.
What?
My calculator is so tired. Wish I could be like my calculator and take a nap.
How do I do it? Oh, wait. I do that. I got the minus. Don't worry.
That's good. I did the plus one.
I did the plus 2.
Oh.
It is 3.22. What's that thing called? Like,
What was the other one, just to make sure I got the same thing? What'd you have?
oh, I had 1.45.
1.45. Okay.
What am I gonna say? Like, I feel like I've heard people say it's called the derivative or something. Like, where it's just the 4ac. Is that what that's called?
That's the discriminant.
Oh, discriminant. That's what it's called. Yeah.
Why does there have to be discrimination in that? There's already enough of that in the world.
Yeah.
You know, it's just holding to the trend of the norm, I guess.
I guess.
Though I'm pretty sure this has been, well, I was gonna say this has been a thing a lot longer than that, but maybe not.
It's following the normal model.
Yeah, you know. Depends on the day.
Yeah.
You get that?
Nope. Gonna pretend like I do that.
We haven't done a whole, well, we've done stuff with the normal model. Not a ton, but we've done stuff with the
We
normal
did a
model.
few things with it.
Dang it.
I knew it sounded. I couldn't remember what class we learned about that.
Statistics.
I know. But that's the one that goes like that.
I don't know why it said it like
I wish I
that.
got lowercase.
Statistics. Statistics.
We only have 10 minutes left. Whenever I go to look at the time, I just look at the microwave clock.
I mean, it's actually right, so.
Is it? For
Yeah.
once?
One day
Virginia
I'm gonna
fixed
look
it.
and it's gonna be so off and it's gonna like mess
Virginia,
me up.
didn't you mess it up and then you fixed it?
Yeah, I messed it. I accidentally one time was microwaving something and I instead reset the clock and it was really confused.
And then she went to fix the clock,
It didn't work.
and then like it kept on like going back after like 30 seconds. It was so funny.
And I guess we're going to.
All right, this one says a body's velocity at time t seconds is the equation I wrote. Find the body's speed each time the acceleration is 0.
So do we just like take the discriminant twice and set equals 0? What? Was that stupid?
Yes.
Say it one more time.
I don't want to.
Idiot.
What?
Say it.
Say what?
Whatever you said.
Find the what?
Oh, I mean whatever. You know what I meant.
I was like, huh?
Now I can't remember that word. What is it?
Derivative. Okay, so I need to take the derivative of this because this is velocity. So I need acceleration. Derivative of velocity is
6t squared minus 18t plus 12.
so now I set this equal to 0. What do you notice though?
It's it's a perfect, a trinomial, no.
We have.
What do all these have in common? Mhm. So that would leave me with t squared minus 3t plus 2. Because if I take out the 6, 0 divided by 6 is 0, so I'm just not writing it. What does this factor into?
T minus 2 t minus 1.
Equals 0. So t equals?
2 or 1.
Yep. So then to find the speed when the acceleration is 0 is I'm going to take that time and plug it into the velocity equation. So I'm going to have v of 1 is 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 minus 5.
Wow.
And I think this comes out to 0. Maybe.
I think so too. Looks like 0.
0 meters per second. So at time 1 second, it's 0 meters per second.
This is not going anywhere.
Then v of 2,
I'm just gonna take that.
2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 5. Is that 16 minus 36? So negative 20 plus 24 is 4 minus 5 is negative 1. Yes?
Yeah, that sounds reasonable to me.
Now, technically, I'm finding what?
Speed. So
Which is the absolute value.
Yep. So keyword is speed, so this is actually going to be 1 meter per second. All right, inflating a balloon. We're just doing part A, I think.
all wrong.
Or well, we might be doing part B also. Inflating a balloon. The volume V equals 4/3 pi r cubed of a spherical balloon, changes with radius. Part A, at what rate does the volume change with respect to the radius when r equals 2? Only if you want to be with 8th grade. I think you'd rather go to government.
That's honestly debatable. Do you know what president should I pick for the Instagram?
Grover Cleveland. He's the 22nd president. One day I just wanted to know that, so I just searched it up. Now I
What's
just
the 22nd president list?
Yep. Grover Cleveland. Could you
Fumble. I got it. Maybe. I got it.
work?
Okay. So, the rate is volume changing, or like what rate is that? We would need to take the derivative. So what is dVdr?
DDR. 4 pi r squared.
4 pi, whoops,
I think.
r squared.
Sure. I think that's what I said. Although
So-
I said dBdr, not dVdr, because I heard you say B, and I was like, that's where we're going with that.
When the radius is 2, I would have 4 pi 2 squared, which is 16 pi. And that would be cubic feet per volume of radius. Wait, feet of volume, sorry.
Don't you just love when your feet are shaped like cubes?
Per foot of radius.
Not gonna lie, but it looks like food right now.
All right, so then part B wants to know by approximately how much is the volume increase when the radius changes from 2 to 2.2 feet. So I use the same equation, but I plug in 2.2 instead. So this would be 4 pi 2.2 squared equals, we're running out of time, so that's 60.8. Minus, if you did 16 times pi, you would get 50.265. And so that approximately will be 10.556 feet cubed. And that would be that part. So basically just reevaluate it at a different number and then take the difference of the two numbers. All right, problems, but you'll have, since y'all are going to the thing tomorrow to talk to the rep, you'll have time like while you are in class to do them. So 1, 9, 11. Hold on. On 11, just A and B. 15, 21, 23, 42, and 43. Those are just multiple choice questions that are like AP type questions. That's why. So they're not too scary.
Was the pod question just supposed to be how, like, started